Preparation of oxygen using hydrogen peroxide. Hydrogen peroxide is a colorless, heavy, strongly oxidizing liquid. Its chemical formula is H2O2. It is highly unstable. It is used in the preparation of oxygen gas in the laboratory. Set up the apparatus as shown here. Some manganese dioxide and water is taken in a conical flask. Hydrogen peroxide is added dropwise through the thistle funnel. You will see that the oxygen gas comes out through the delivery tube. Oxygen gas is collected by the downward displacement of water.
All living things are kept alive by doing chemical reactions. In fact, some estimate that your body performs around 500 quadrillion reactions per second. That's a lot. These reactions would keep you alive and are done by special molecules called enzymes. So enzymes are super important. No enzymes, no life.
We all dead.
So what are enzymes? Enzymes are proteins that speed up chemical reactions to make them happen. Here's how they work. The Pac-Man looking thing on the left is an enzyme. Notice that it has a little triangular region that looks like its mouth. That is called the active site, and it's where the reaction happens. On the right, we have a molecule in the shape of a triangle. It is called the substrate. This is the molecule that will undergo a chemical reaction. Notice that the substrate fits perfectly into the active site of the enzyme, just like a puzzle piece. Each enzyme can only work on specific substrates to do specific chemical reactions. So we say that enzymes are specific. When the substrate enters the active site, the enzyme weakens the chemical bonds in the substrate, causing the chemical reaction to happen. The molecules that are produced by the reaction are called products. The enzyme is not altered by this reaction and can be used again and again. Although this animation showed an enzyme breaking down a substrate, there are other enzymes that do the opposite. They take substrates and join them together to make a larger product. If you enjoyed this video, please like it, subscribe, and check out the other free games, quizzes, and interactive learning experiences at Bioman Biology.
So this is the potato experiment with the enzyme catalase. The first thing we did is we prepared our potato. So we made some marks on our potato and we cut a 1 centimeter wedge in the middle of our potato. Now in this video I'm recording at high speed just to sort of remind you of the process of what we did. So be very, very careful if you're redoing this experiment or doing it for the first time, as it is high speed. I'm nowhere near using the knife at the speed that it appears because I'm just giving you a summary of it. Then we cut a 2 centimeter section, and then we cut 4 half centimeter sections like you see there. And again, this is high speed, so I'm really not cutting this quick. And so the result at that point is we have our 4 pieces of potato, 1, 2, 3, and 4, and they are 1 centimeter by 2 centimeters by half a centimeter. All right, so potato 1, 2, potato 3, we're going to cut it up into small little tiny chunks, as you see there. And the goal of what we're doing there is we are creating a potato, the same amount of potato as the others, but this one will have a much higher surface area because of cutting up the potato, as you see there. So 1 centimeter by 2 centimeters by half a centimeter, and then potato 2 we're going to put in boiling water for a few minutes. Then we set up our test tubes, and we have 4 test tubes, 1, 2, 3, and 4, that will correspond to our potatoes. The liquid inside the test tubes is hydrogen peroxide, and then in test tube 4 we also put 1 milliliter of acetic acid or vinegar, and we put water for 1 milliliter in test tubes 1, 2, and 3. Then we put our potatoes in, and we have test tube 1 with a regular potato, test tube 2, the one we boiled, test tube 3 has the potato we chopped up, and test tube 4, normal potato but with acetic acid. And then we let them sit, and what you see is the enzyme taking action and doing the chemical reaction, which is taking the hydrogen peroxide, H2O2, and converting it into water and oxygen. And that enzyme catalase is found inside the potatoes. And you can see in test tube 3 that by chopping up the potato and increasing the surface area, we allowed more of the enzyme catalase to come into contact with the substrate, which is hydrogen peroxide, resulting in more bubbles. So again, test tube 1 and test tube 3 give you the best results. By far, test tube 3 works the best. Test tube 4, the enzyme's been denatured. And in test tube 4, we've also denatured the enzyme, but we've done it chemically by adding acetic acid into it. So that is the catalase experiment summary.